Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Kita jumpa lagi dalam video to explain about basic chemistry. Okay. We look at the octet's rule in explaining why atom forming a bond with another atom to form a compound. Okay. Normally, atom will try to become stable, okay, by achieve octet's rule. So, what is octet's rule? Octet's rule is the simple chemical rules of thumb that state that atom tends to combine with another atom so that each atom will have 8 electron in their valence shell. Yeah. So each atom have 8 electron on its valence or outermost shell, yeah, yang paling luar. Okay. Atom either gain or lose or share electron with another atom until they obtain 8 valence electron or octet's rule. Okay, the same number of valence electron as the noble gas closest to them in the periodic table. Okay, so each atom try to meet that rules, yeah, because the most stable elements is the noble gas or noble gas, which is in the period in a group 18 or group 8. Yeah. Okay. An octets of electron consists of full S and P subshell orbital in an atom. Yeah. But for hydrogen, it is only 2. Yeah, because hydrogen will not achieve octet because it only have one orbital, which is S orbital. Okay. When atoms form covalent bond, they tend to share such sufficient electron to achieve outer shell having 8 electron or to achieve octet's rule. Yeah. This indicates how all atoms in a molecule are attached to one another and account for all valence electron in atoms in a molecule. Okay. Let's look at some example of noble gas. Yeah. Because all noble gas will have this valence electron, yeah, NS2 and P6 valence electron, which is the most stable monoatomic gases, and it does not require to form a compound or to combine with another atom, okay, because it is already stable. But octet's rule only work well with group 1A and 2A metal, with aluminium, with non-metal, okay, okay, this one yang merah-merah ni, and yang putih ni, okay. But hydrogen and helium cannot obey octet's rule because it has a limited 2 electron only in the n is equal to 1 shell, yeah, because hydrogen and helium is in period 1, so it only has S orbital, okay, and it also doesn't work with transition metal and post transition metal. Yeah, post transition metal, okay, somewhere here. Okay. Okay, for drawing Lewis structure, kita dah tengok, so saya tak nak discuss drawing Lewis structure. But formal, okay dah. Semua kita dah tengok dah, ya. How to determine stability of the Lewis structure by considering which formal charge is more stable by calculating the formal charge of each atom in each atom in a Lewis structure. Okay, ada contoh dekat sini. Kamu boleh gunakan contoh ini, contoh-contoh tu untuk buat formal charge. Okay. Now we look at the exemption of octet's rule. There are some cases that does not really follow the octet's rule. We have 3 cases. The first one is expanded octet. The second one is incomplete octet. The third one is odd number electron. Okay, so these are the 3 cases that does not follow octet's rule. Okay, so let's look at the detailed discussion on each of these. Okay, so the first one is expanded octet. Some elements after period 2 in the periodic table has large are large atom. It has d orbital, and sometimes it can accept up to 18 electron. And the Lewis structure follow the same process as drawing Lewis structure before, but by adding extra electron to the central atom. Dia memang akan ada extra electron. So nanti kita akan tengok example of expanded octet. Okay, in the case of phosphorus pentachloride, because each bond is actually 2 electron, so 2 times 5 is 10 electron. Okay, jadi phosphorus pentachloride is the example of exemption from octet's rule in case of expanded octet. Lebih daripada octet. Okay, this one. Because dia boleh expand dia punya shell tu kepada because it is in the third period, dia boleh guna dia punya d orbital. Okay. Okay. Let's look at the explanation for the expansion octet. Atom of element from period 3 onward, period 3, period 4 dan ke bawah semua tu, may have more than 8 valence electron in their compound. This is due to the existence of empty d orbital. Remember, kalau dia sampai period 3 ni, dia boleh ada sampai d, 3d. So even though there are lack in electron, but the orbital is there. There is an empty room. The electron can be filled up, either electron from other atom or electron from the atom itself can jump to the empty orbital to make it to form a bond with another atom. So this is example, 2 example of expanded octet. Phosphorus pentachloride and sulfur phosphorus pentachloride, yes, pentachloride and sulfur hexafluoride. Okay, kamu tengoklah dia ada, yang ni ada 12, yang ini ada 10 elektron. Okay, so this is how the electron form a bond in forming 5 bond. Kalau tak, dia boleh form 3 bond je kan, tapi this electron will delocalize or jump to d orbital, so dia boleh form 5 bond. Okay. The second case of exemption from octet's rule is incomplete octet. In the case of lithium, beryllium, boron, and aluminium atom, which has less than 8 valence electron in a compound, okay, normally boron will have 6 electron, means that 3 pairs. Boron dia tak boleh nak form banyak dah, sebab dia boron, I think saya tak ingat dia dalam grup berapa, boron 3 kalau tak salah saya. Kedua, nanti tengok balik. The same with the beryllium. Beryllium pun normally dia 2 pair sahaja ataupun 4 elektron, ya. Ni 6, ni 4, ya, 4. Tak cukup 8. Okay. So this is example of beryllium, boron dengan aluminium. Yeah, boron and aluminium 6, beryllium 4. Okay. Okay, so this is the explanation here. Because this ion have high charge density that enable them to attract the electron strongly, resulting in sharing of electron. Yeah, okay. And this is the same incomplete octet. Yeah, boron. Okay. Okay, this one, yeah, boron. For this one, yang ini dia tak go to a higher energy orbital. Dia tak masuk dekat tempat kosong ni. Ya, dia tak masuk. Okay. Yelah, semua tu adalah jawapannya, tapi kita tak tahu kan. Semua tu rahsia Allah kan. Okay. Okay, and the last of the three tadi kan, kita ada expanded octet, incomplete octet, and number 3 is odd electron molecule. Okay. In some molecule, it contains odd number of valence electron. Most odd electron molecule have central atoms from an odd number group. Yeah, for example, nitrogen and chlorine. Yeah. So odd electron molecule include nitrous monoxide, nitrogen dioxide, and chlorine. Yeah, saya tengok apa chloride ke chloride ni, nama dia. Okay. So inilah keadaan dia. Ya, inilah Lewis structure dia. You see this nitrogen ni ada 2, 4, 6, 7. Okay, dia ada 7 je. Kalau fluorine ni pun sama juga, 2, 4, 6. Okay. Oh, sorry. This is not the explanation for odd electron number. Ini exercise untuk draw Lewis structure. Ya. Sini je lah, satu je contoh untuk odd electron molecules. Okay. Okay, so I think we finish with the bonding. Yeah. Okay, formal charge. Oh, okay, formal charge. Okay, kita stop dulu. Nanti saya buat another video for formal charge. Yeah. Thank you for your listening. Assalamualaikum.